Hi, my name is Victor. Today we're going to talk about time event data and plotting a chart using a time between control chart. Let's look at the data. The data consists of a sample population of 352 infants. When an infant within the sample showed at a clinic, a data referral was reported. The questions we want to try to answer are, how has the data referral rate changed over time for the following clinics? Also, what is the daily probability for each of the above-mentioned clinics and combinations? Note, multiple referrals occurring on the same day should be equivalent to one referral. The control chart calculations consist of days between events, median, lower fourth or upper fourth spread, and upper control limit. Note, the lower control limit is 0, but will not be plotted on the chart. Let's begin. So on the right side of my screen, I have all the data for ultrasound. The dates that consist of each referral for the 352 infants. So the first thing we want to do is highlight column A, go to data, and remove any of the duplicate dates. The next item we want to do is order those dates from oldest to newest. So now we have oldest to newest. The next item we want to do is calculate the days between each date. So equals the current date minus the previous date. And then we want to copy that equation all the way down to the last value in our data set. The next item we want to do is copy that data and paste it into a new column, in this case, column E. And we want to order that data from smallest to largest. The next item we want to do is calculate the median. And that median is equal to 4. So I'm going to come down through the data set and highlight 4 in our data set. And notice we have 7 4s in our data set. So I'm going to highlight the middle 4 of all the 4s. And so the lower fourth consists of all the numbers above the highlighted yellow 4. So we need to take the median. Those values. And the upper fourth consists of the median of all the values below the highlighted 4. Yellow highlighted 4 in this case. So the upper fourth equals 8. So the fourth spread equals upper fourth minus lower fourth. So 5.5 is the fourth spread. And now we need to calculate the upper control limit. So that equals the upper fourth plus 1.5 times the fourth spread. In this case, it's 16.25. So we're going to come back over to column C and type equals and $2, and that keeps the cursor in the appropriate cell as I copy the value down through all the data set values. And now we can actually highlight column A through column C and produce our control chart. So I'm going to highlight column A and column C, going to insert a line chart, select the appropriate line chart in this case, and we can notice that there are 2 dates that are above the upper control limit. But for the most part, our referrals are in control, but they're quite frequent, as you can notice. So we're going to do the same for neurology as we did for ultrasound. And in this case, I've already calculated the values. And we note that 10 is the median. So the upper fourth consists of all the values, including the second 10. And then the lower fourth also includes a 10, but it's the first 10 that you arrive to in our data set. Our upper control limit is 42.75. So now we can actually highlight the values that we want to chart. So I'm going to insert the line chart I want. And as you can note, there are still 2 referral dates above the upper control limit, but it seems as though neurology are referred to infants in clusters in this case. So that's one thing to note. And now we want to do the combination of neurology and ultrasound. And in this case, I've put all the dates of ultrasound and neurology into one column. I removed the duplicate dates and ordered them as we did for ultrasound in our first graphing, and calculated the median, the lower fourth, and all the other values that we need. In this case, we have the median is 4. We have 12 fours, so I highlighted the first 6 and then the second 6. So the upper fourth consists of all the values, including the second highlighted yellow 4 below in our data set, and the lower fourths consist of all the values above. In this case, we'll highlight all the values that we need to use in our data set to produce the chart. So I'm going to highlight the values, insert, select the line chart that I need, and as you can note, we have many referrals for ultrasound and neurology, but it seems as though when they are combined, it brings down we put our referral dates more into control, because now we only have one date that's above the control limit, upper control limit. So, as you note, we have several graphs, but several referral dates, but for the most part, it seems as though referring an infant to both neurology and ultrasound seems to bring our referral dates in control. So the next thing we want to do is calculate the daily probability. So the daily probability consists of finding the number of dates within a clinic and then dividing that by the difference of the max and min date. So here I have all the dates without removing any of the duplicate dates, and I'm going to put my cursor in cell F2, type equals, count, and I'm going to count all the dates for ultrasound, divided by the max for all the dates minus the minimum date and we note that the daily probability is about 0.21 or 0.21 for ultrasound. So let's calculate that for neurology and then the combination. So I'm just going to edit this calculation a little bit. So that the data set is pretty much static, so when I copy the equation over, it won't move. So I'm going to do that. In this case, I need to edit the combination here. And now we have the daily probability of neurology and ultrasound and neurology. As you note, that the daily probability of ultrasound and neurology also it's representative in our control chart, that it's higher than most than being referred to ultrasound or neurology. So the next one would be ultrasound. The infant would be more likely referred to ultrasound than neurology. But for the most part, ultrasound and neurology has a higher referral rate.